Hello, very good evening, my dear students. Today we are going to start our grade 7 class, and this is very special day because this is the very first day that we are going to meet and we are going to start our class. And note that this is YouTube premiering session. So why I have planned this session? Because this is the first day. Most of the parents, they are calling me and they are asking how to join and how to join in the class, how to configure Zoom or how to join it Edmodo, LMS. Likewise, they are asking various questions. So there will be more interruptions if I'm going to do this live. That's why I'm doing this in recorded live mode. And also another thing, so when we are doing classes in Zoom, we have to do it in real time. That is also very good because real time we can see each other and we can communicate with each other. And at the same time, you can raise your hand and ask questions, and you can live contribute to the lesson. So that is there. But there's a disadvantage as well. If I get any interruption, any kind of interruption from power or connectivity, you all have to suffer because you are from different region. So some regions they are having good connectivity, some regions it's not. So my region is kind of average. I'll get signals on and off sometime. And similar about the power interruptions are also there, sometimes, not always, but there are some failure, like 5% like failure rate. So therefore, so when I'm doing this premiering session or the recorded live sessions, so it's easy to you to, or it's convenient to you to be connected and watch the lesson. And at the same time, I'll be there live in this section, so you can always ask questions, but not using your voice. You have to use your hands. You have to type the question and ask in the chat section where I can reply to you. So that is the way that we are using the premiering feature. Premiering feature is very good because we can connect people in a given time slot. So, and the only disadvantage is you can't raise your voice and ask a question like so, right? Okay, let's continue. Before we begin, I should remind you that what we are using in grade 7, actually what we are going to learn in grade 7, mostly the things that you have learned in grade 6 will come to grade 7. That means you have learned the primary or the fundamentals in grade 6. In grade 7, you will be learning the intermediate stuff. The intermediate stuff will be given. That means same thing, same topics, but little bit more than grade 6. So if you have not completed grade 6, my advice to you is join with grade 6 class also while coming to this class, because we will be starting, we are starting grade 6 class today itself. Therefore, you can come to grade 6 for free while coming to this class. That is an additional thing that we have given to you. If you have not covered grade 6 syllabus, please come to grade 6 class as well. Don't stop this class, come to this class, also come to grade 6 class. And another thing, that if you are having any kind of language problems, if you're having language issues, then we allow you to come for Sinhala medium class as well, because English medium class basically it will be conducted in English medium, and there's a Sinhala medium class going in parallel with this. Therefore, you can, but not in the same time, you can come to Sinhala medium class as well. So you can watch Edmodo LMS notification. So there I have published all the class and class schedules. If not, you can just contact me and I'll give you the class schedule. You can come to grade 7 Sinhala medium class while coming to this class. That is also additional benefit given to you. Okay, let's go and explore our syllabus first, right? In this syllabus, we will be learning, this is the table of content. So in this syllabus, we will be learning about central processing unit, which is like, it's like a brain of computer, one of the mandatory and most required, most demanding and valuable component inside your computer. So that is central processing unit. We will be learning and exploring about that. And that is kind of theory lesson. Then we will be learning about operating systems. That is the second chapter. In the second chapter, we will be exploring more practical stuff. So we will explore computer using an operating system, not just single operating system. We will be learning about Windows and Linux-based operating systems like Fedora Linux, Red Hat Linux, Ubuntu Linux, Kali Linux. Likewise, we will be exploring Linux-based operating systems, as well as what I am using now is Mac OS. I'm recording these lessons using Mac OS, so you can just see the interface there. But some of you might be familiar with this Mac OS as well. We will be learning about that as well. Not only that, we'll be learning about mobile operating systems as well as command line interface, which was kind of old, but still we are using command line interface because it's one of the powerful interface that we had and that we are having. Also, we will be learning about graphical user interface operating system. Okay, that is the chapter number 2. Okay, now let's go to chapter number 3, security of computer system. Security of any system can be measured in two aspects. One is the logical security, two is physical security. The logical security means we will be learning the facts that protect your computer from internal issues, operating system related issues, or whatever you can't physically touch. So those things should be secure. That is most important. One thing is data and information. You know, I don't know whether you know this. Information is termed as one of the most valuable economic resource in the world. So it's valuable than gold, it's valuable than platinum, and valuable than crude oil, whatever you say, it's valuable than everything because information is kind of most valuable resource in the world. So if you have information, be happy, you have some value, not some value. If you have good information or information that others don't have, then it has big value actually. So that's why it's called one of the most valuable economic resource. Why? So think about that. Think about if you're having passwords or username and password of Mark Zuckerberg. If you're having username and password of the admin panel of Microsoft admin or the kernel access that information. So think that what you can do. Never imagine, right? So that means information. That's why if you have bank ATM numbers, PIN numbers, passwords, ATM cards, and if you have credit card numbers with their security credentials, those all these are information, but it's more than money. If you have if you have account number, account details, or credit card details of an account which have $1 million, or more than that, likewise, think about the things that you can do with that. So but I'm not encouraging you to hack, I'm not encouraging you to cheat or take someone else's money, but the thing is, information is such valuable because there are some people, if you cannot protect your account credentials, then again you are in trouble. Because if you are having money in your account, if you cannot protect your credentials, means username, password, PIN numbers, ATM cards, you name it, whatever related to the account, those are sensitive information. If you cannot protect that, it will go out and others will make use of it. So that is the thing, right? Okay, then we will be learning about that such security aspects like logical security as well as physical security, means how you can protect your computer from outside noises, dust, pollen, and maybe fungus by rain. Likewise, how you physically protect your computer and information technology resources. Then lesson number 4, chapter number 4, it is one of the most important practical lessons we will be learning, word processing. Not just using MS Word, we will be learning ABI Word, and we'll be learning Open Office Writer, and lot of software components are there, because not just MS Word, we will be learning many application software programs which can use for word processing. And then one of the most important component, actually I name this chapter 5 as the most important chapter in your syllabus, because there will be learning programming. We need at least few months to learn program, because programming is not easy. How to instruct computer to do something is the programming. So we will be learning that at least 2 or 3 months. So that is practical exposure to programming. In grade 6, sorry, in grade 6 you have learned programming concepts. If not, I said that you can come to grade 6 class as well. So we learn programming concepts, but the implementation part we will be learning in grade 7. Then the presentation software. Presentation software means you will be learning PowerPoint, Impress, yeah, PowerPoint and Impress, basically how to create a presentation, how to manage presentation. Maybe you can create small programs using presentation, or kind of games or puzzles using presentations. We will be learning that aspects as well. And then the last chapter, this is quite similar to the last chapter of grade 6, which is internet and information communication. In there will be learning how your computer is connected to the outside world, and how you are dealing with the outside world, what kind of services that you can get from the outside world, and how you access and use, how internet manage things. Likewise, we will be learning many things. And not only that, one important thing, we will be creating our first website there in this chapter. That means after completing this chapter, you will be owner of a web page. You can start, maybe you start your own e-business, or you can start blogging, whatever. If you like any other thing, maybe if you like e-money, if you like to earn something using internet, you can use that skills there. And that is after implementing your first website. Sometimes there are students who have already done this, who have hosted a website and managing a website. This is not for them. So for newcomers, we will be starting that web development and designing, basically web designing part. Okay, I think now you know the basics that we are going to learn. And the first chapter itself, it says what is central processing unit and all these things. And actually we will look into this. But before looking into this, I just wanted to share you some information about common or general facts about computer and how it began, history of computing. Likewise, I have to share that with you. Why? Because if you know about the history, then if you know about the present, it is always easy to predict the future. So we are learning this for future, right? We are learning this for future. Why I'm telling like that? Because when I started learning ICT in grade 6, I was there in grade 6 in 1996. So that time I was starting learning ICT. And I can remember we had CLI machines, command line interface machines, and we had a set of floppy disks to run operating systems, and programs like QBasic, GW Basic, Pascal, Lotus 123, WP51, those were the programs. But if I'm going to teach you now about those programs, let's start a class about WP51, Lotus 123. No one will join. Why? Because IT, it was not the one which was there in 1996. Now it has changed significantly. So we didn't have even color computers at the beginning. But now you have laptop, PDAs, even your computer can be kept in your palm tops, personal digital assistants. Likewise, you have computers, mobile computers. We didn't have that opportunity in that time. We didn't have internet initially. Later only we got internet, and actually we were used to go cafes to access internet. it was not it was not a facility given to home, but later it was added. Now everyone is connected. It's like almost like 99% of Sri Lankans are connected using internet. So now situation is totally different. So that's why we are learning this for future. We have to teach you the stuff that never ever started yet. But we have to teach you the stuff to work in future environment with future technologies. Those future technologies not yet invented, but you will be working with that future technologies. So this is the challenge to most teachers, because teachers cannot teach current things and then keep shut. So these are the things. And likewise teach in Sinhala or Tamil or mathematics, what science, whatever the subject, they can teach you the current trends and the things. Then they are okay. But in IT, it's not like that. It's challenging. It's really, really challenging. Whatever that I'm going to tell you now is going to change tomorrow. So why I'm teaching history still? Because history repeats and history is very important. History is the foundation. Then only we can move forward and we can predict the future. So we should teach you how to predict future. Then only you can guess about the future and learn for future. Right, let me go. History of the computer. Basically, you're not supposed to remember each and every staff lines, each and every name, year, everything here, because this is the common note. This is given for even grade 6, 7, 8. Even this is even given for grade 11, 12, all the students. So this is common thing. So you're not supposed to remember everything. Just remember the key areas. Initially in the ancient era, people were interested in calculations, and they found using their fingers, they have done the calculations. But they found that if they have used symbols, if they have used symbols, this can be that symbols can be used for more powerful calculations. Therefore, they have introduced symbols, various symbols like Roman numbers and other number systems they have introduced. And they were not happy with that as well. They think that still it's not easy. If we can introduce machines, if we can introduce machines which can do the calculations, that would be better. Likewise, they were thinking at that time they have introduced very 5,000 years ago they have introduced something called abacus, which is shown in this picture. It was in pre-mechanical era, before 1450, pre-mechanical era, 5,000 years back. They have introduced this kind of machine which is quite similar to today's abacus, and this was used for calculations. Then in the mechanical era, they have introduced some machines, but no electricity, no power was used. These used just valves and levers, so which can be switches and all, but not with power. All these were manual and mechanical. So this picture shows Pascaline, which was developed by Blaise Pascal in 1642. Blaise Pascal has developed the Pascaline. And to give input to such machines, this Wilhelm Horn Leibniz, here, that person, he has introduced something called punch card. Punch card. This punch card just to give inputs. It has different set of holes. By changing these hole patterns, these hole patterns, so Joseph Jacquard introduced something called Jacquard Loom. By changing these hole patterns, he found that it was possible to change the weaving style or weaving the pattern by changing patterns of this paper. When you change the pattern of this paper, the weaving pattern was changed according to that. That was his founding, and this is not actually a computer. This was a machine. And if you can remember these two pictures, it's better, because this person, I think we should remember, because we should respect him, because today's computer concept, which has the abstract model of information. Abstract model of information, that means abstract model of information means you give inputs, process, and take outputs. Today also we are doing this, no? We give inputs using keyboards. We give input using keyboard, mouse. Computer will process that, and it will display the output to us using monitor or speaker. Likewise, they will display it, or they will give us a sound. They will display in the monitor. They will take a print out and give us as a hard copy. Whatever we give input, it process and give output. That model is called abstract model of information. Remember the term, okay? Abstract model of information. We call that abstract model of information. Okay, he has introduced his analytical engine, which is shown in this picture. He has introduced his analytical engine, and this was not perfectly working machine, but it was a machine model, and it has he has developed some components of it. Anyway, concept is belongs to him. That's why he is called father of computing, right? He has introduced this analytical engine, which was capable of taking inputs, process, and produce outputs according to this abstract model of information. Therefore, he is called father of computer. He has introduced in mechanical era 1930. Then, when it was that electromechanical era, electronic was added to his inventions, and electronics was added to his inventions. Then the computers like Mark 1 in 1944, computer like Mark 1, which is shown in this picture, were introduced. They have implemented the concept suggested by John von Neumann and Charles Babbage, suggested by Charles Babbage. Who's this lady? She's assisting to Charles Babbage, and she's called the first programmer. Why? She suggested that giving giving set of instruction to the computer is possible, and by giving such instructions, it is possible to change change outputs based on the inputs, Then, because initially the machines were generating output just by analyzing inputs and according to given instructions. But this lady, she introduced the concept of programming, where instruction can be saved and applied to a computer. Therefore, she is called first programmer in the world, Lady Ada Lovelace. He's Charles Babbage, and she is Ada Lovelace. So girls, be proud, because the first programmer in the world is a girl or lady, right? Okay. Then in the electronic era, after the electromechanical era, this is also electromechanical era, the first electronic computer, even though we call the first electronic computer, we still call this as a electromechanical computer, because it was not just electronic, it has electronics plus some mechanical components. And ENIAC, electronic numerical integrator, analyzer, and computer. It was the first electronic computer introduced to the world. It has like garage size control room, and spread across it was spread across a building. It's a very large computer which cannot be moved, right? So that kind of computer says that it has approximately 5 million hand soldered joints. Think about the size of the computer, and it has 18,000 vacuum tubes. One vacuum tube, it's like half a feet. So it's 18,000 vacuum tube. Then 5 million hand soldered joints, 7,200 crystal diodes, 1,500 relays, and 70,000 resistors, 10,000 capacitors. You might not know about these technical jargons or technical terms. Just Google it. You have your friend Google. So because this is not relevant to your syllabus, I'm just telling because it's there in the note, but this is not relevant to your syllabus. I said, just remember the key features. Then let me summarize what you have learned. We learned that we had era, pre-mechanical era, mechanical era, electromechanical era, and electronic era. What is the era that we are in now? Now we are in electronic era. So what was the pre-mechanical before 1450? It's pre-mechanical. Then intermediate period, it's mechanical. Then electromechanical. Pre-mechanical era, abacus was introduced. Mechanical era, Pascaline machines and all came in mechanical era. Jacquard Loom, Pascaline machine. Electromechanical. At that time, there were introductions of things like 1940 to now, actually So there was some there were some computers, not actually computers, large machines like analytical engine, Mark 1. Then electronic era. In electronic era, actually, ENIAC, EDVAC-like computers were introduced. This is ENIAC, this is EDVAC. And you can see, even though we call computers, you cannot see any monitors there because the output was given using printer. Here you can see printer. Output was given using printer. Screens were not used, not much used actually. In the end of this era, screens were introduced. Then after then in 1951, after that IBM inventions, basically after 1950s, closer to 1960s, in transistor was introduced. Transistor is a component. Let me show a picture of vacuum tube and transistor, then you can just compare. Vacuum tube was transistor, vacuum tube was transistor. You can see in the comparison. So vacuum tube is kind of this. Vacuum tube is, it's like a half a feet size. That this is a smaller one. Okay. Initially, vacuum tube was very large one, so half a feet size, and this is like a few millimeters. Actually, including this nodes, it's like 1 centimeter maximum. So it was very small device. So vacuum tubes were replaced by transistors, means there was a big change in size when it comes to the second generation. Second generation computers, transistors were used. So size of the computer was reduced. In third generation, they have introduced something called integrated circuit. So IC is, I can show in the single picture, yeah, this one. You can see vacuum tube, then transistors, then integrated circuit. Integrated circuit consists of thousands of transistors inside this silicon chip. Thousands of transistors inside this silicon chip. Big value, no? Right. So then, okay, this is actually Apple I machine. Apple I was not much popular. Even in the first generation, second generation, third generation, so they have not introduced anything for personal use. Third generation, of course, we had some, but not much. For personal use, computers were introduced in fourth generation. Fourth generation, in the early first generation, this is Apple I machine motherboard. You can see Apple I machine motherboard. This was not much popular when it was introduced, but later with the time, the Apple II got 6 million units sold by 1984. It was introduced in 1976. Within 8 years of time, it got 2 million units sold. So you can see how popular computer was at that time. Then by today, it is not just 6 million. Just go and Google and just try to find how many mobile phones sold within a day. Within a day, how many mobile phones are sold. Just imagine. You can't imagine the number even. Right now, it is that much popular. Computer now, it can be kept in your lap. It can be kept in your palm. So it can be kept in your desk. It was earlier as well, but now you can keep that in your palm. Not just that, it can be kept in your eye, it can be kept in your ear. That kind of computers are there now. So very small size computers. IoT. I think you have heard of the term Internet of Things. In Internet of Things, we try to connect computer to everything. Sometimes we call Internet of Everything. We try to connect components to each and every component. Even we try to connect our bulbs. We try to connect home. We try to connect vehicle, animals, pets. We try to connect everything. Mugs, caps, anything can be connected to internet. So those are computers, small size computers, micro size computers. So main features, please remember, first generation vacuum tubes were used. And these are some features, common features. Just go through this because no point reading the same thing again. Anyway, very large computers, less reliable, high power consumption, and it was generating high heat. But when it comes to second generation, because of the transistor size reduced, heat reduced, power consumption reduced, and reliability was increased. And these are some examples. IBM and these computers, these given in these pictures are some examples. Then third generation, integrated circuits, ICs introduced. As I saw, as we saw in the picture, ICs introduced. ICs consist of thousands of transistors. Therefore, computers become smaller and smaller in third generation. So this was personal data processor PDP computer. But you can see, even though it called PDP, its size is large, like a photocopy machine like size. But anyway, these were the computers in the initial fourth generation. And first generation, one important thing I couldn't mention, that in first generation, they have used machine language. What is machine language actually? So you'll be learning these things in future, right? But let me explain. What is machine language? Machine language means something like how you command your bulb in your room to lighten up. How you command bulb in your room to lighten up. To bulb, we press a switch and pass the electricity, then bulb understand, I should lighten up. Then if you disconnect the power by closing the switch, then bulb will off. Connect the power, bulb will on. Disconnect the power, bulb will off. So remember the way bulb is connected using power. This on off is denoted using 1 and 0, and that is called machine language. This on off scenario, this on can be represented in 1, off can be represented in 0. So this is called machine language. Right. Then it was evolving, like in the second generation, evolved to the second generation languages like assembly language. In third generation, it was again improved to the high level language. High level languages are like human readable. For an example, you can give print ABC. Print ABC means it's print in ABC. But we can understand, machines still cannot understand that language. Therefore, we use translators. We will be learning these things in future. Otherwise, you will confuse in the first day itself. First day. So therefore, I don't want to make you confused. Just remember that what are the main features of these generations. And then when it comes to fourth generation, those are the computers that we use in fourth generation, and some computers we are using having features in fifth generation. Fifth generation means ultra large scale integrations. Fourth generations, very large scale integrations and large scale integrations. That means millions of transistors are connected to a microprocessor. Here, not even million, more than million. That means very large. Even the large scale integrations are connected and created. These ultra large scale integrations. Those are high-end hardware, and not only that, artificial intelligence features were introduced in fifth generation. What are the AI features? Let me demonstrate one thing. So we have not yet finished fourth generation, but we have started fifth generation. Therefore, we have computers with fourth generation and fifth generation features. So basically, computer uses screen, but in third generation, second generation, first generation, it uses printer as the output device. Third generation, end of third generation, they will be using screen. But fourth generation, screen is common. Now we are using screen. That is a fourth generation feature, basically. Third generation, fourth generation feature. So not only that, it has artificial intelligence. That means computers can think. Yes. Even today, your computer, you have Cortana in Windows and Siri in Apple. Let me show. Can you tell me what is the time now? Siri, can you tell me what is the time now? It is kind of slow, I think. it here what I'm telling, but not exactly. Let me close this and tell it again. Okay. Siri, could you please tell me the time?
It's 4:17 p.m.
Yeah, it's 4:17 p.m. It answers me. And not just that, so you can just ask it from Google as well. So maybe you can ask Google to translate something. Google, let's go to Google. Translate I like you in Hindi.
In Hindi, you would say, मैं तुम्हें पसंद करता हूँ.
Okay, you can hear it. Translate I like you in Japanese.
In Japanese, you would say, 私はあなたが好き.
Google can even act like intelligent person. So not just that, if you want to go for singular typing, you go to site like helakuru.lk, and then you have microphone on. I invite you to just because my internet connection is kind of slow, it's not loading now. I'm sorry for that. So just go to helakuru.lk and turn on the microphone and tell something in Sinhala. Then you will realize, yeah, it's turning on. Let me show. අපේ ළමයින්ට මොනා හරි දෙයක් පොඩක් ලියලා පෙන්නන්නකෝ. Okay, now you can see. You can see that it can realize, it can understand our natural language. So that is future, and this is not that this is what the current situation. This is not future actually. Think about the future. Future is unimaginable. For ready for future, I'll finish today's lesson by this. I think the last practicals will be most important. We'll be doing that practicals. Okay, I'll finish the lesson by today with this. And we have to learn a lot of things. We have to learn a lot of stuff. We will be learning this in next days, next in future. If you are joining with us, we will be learning this with your textbooks. Not only that, we will do a lot of practicals. Practically how it can be applicable, we will be learning that thing. And let's see you on next day. Have a good day. Good night.